Hey guys, hopefully you are super excited about this YouTube video. And if you're not, my apologies. Um, Hopefully it'll go pretty cool, guys. It'll go pretty fast. This is a review. It doesn't cover everything we've done, but it covers the majority of the stuff we've done, and you can expect your semester exam to look very similar to this, plus another 5-6 questions on top of that. All right, so here we go, guys. In the graph to the right, the dashed line graph represents f of x, so the dashed line is f of x, and the solid line is g of x. So which of the following values of x is f of x negative? That's what this means. And f of x less than g of x. Okay, so they give you three x values. X equals -1. So I go to -1, and I'm looking at this coordinate there for the dashed line, and I can see that that's not negative. So that one's out because I need f of x to be negative. At 2, yes, f of x is negative, and g of x is larger than f of x, so that one works. And at 4, it looks like f of x is right on the x-axis, so that does not qualify as being negative. So it just looks like Roman numeral number 2. And that's it, guys. Identify the domain of the function. Okay, so the domain just means where are you defined? Where is this function defined? So if I factor it out, let's see. If I factor this out, 3 minus x on the top and on the bottom, two numbers that give you -20 that add up to a -1. And I believe that's 5 and 4, 5 being the -1, and then x plus 4. So let's see, -5 times +4 is -20, -5 plus 4 is -1, there it is. So where is this function defined? It's defined for all real numbers except -5 and -4. So they don't write it like that, guys. They write it in interval notation. So -infinity until you get to -4, then union -4 until you get to 5, and then union again from 5 to infinity. So we look for that. Let's see. Infinity -4 to 5, 5 to infinity. Here we go. That's that one. And they're trying to trick you with letter A. They put in 3. 3 is something that's called a 0, but that's not what it's asking for, guys. It's asking for where, what's a domain. So hopefully you don't get tricked. All right. So on this one, it says, which of the following statements is true? And you have these three f values, f of -1. Really, all that just means is your y value. So if you start with letter A, let's see, f of -1 supposedly is the biggest. The smallest, and f of 3 is the biggest. So the y value of 3 is 2. At 5.5, you are way down here. Looks like you're at -4. And at -1, you are here. So nope, the 5.5 is the smallest. The 3 is the biggest. That one's out. So since I just said that the 5.5 is the smallest, I look for that, and it has to be between here and here. And then which one's the biggest? At 3. So it has to be this one. In case you're wondering, Chavez, what are you talking about? The value at 5.5 is -4, so -4 less than, and the value at -1 is -2, and then the value at 3 is 2. So yeah, 2 is bigger than -2, and -2 is bigger than -4. And that's it. All right, let's go to the next one, guys. Which of the following statements is or false about the graph f of x? The domain is -5 to 6. Notice there's an open parenthesis there with a bracket. So let me erase these guys so I can see if I have a hole or not. That one seems to be true, and one that is false. The range is -5 to 6. Let's see, -5, 6. So this one appears to be false. And f of x is 2 when x is 1. All right, when x is 1, yeah, it appears to be 2. That just means f of 1 equals 2. So that one seems to be true. They want one that is false, so it looks like just Roman numeral 2. So look for that. All right, let's go to the next one, guys. If the function f of x is an odd function, so it's talking about odd functions, so odd functions have this property. Is an odd function on the point -3, 2 is on the graph. Which of the following points must be also on the graph of f of x? So this is it's a flip, guys, or symmetrical about the origin. So what that means is if I have a point at -3, 2 point, if I do a flip and then I do another flip, this is the point that I'm talking about, 3, -2. So that's my point, 3, -2. And that's what it means to be odd, guys. So here we go. Suppose that the point 2, 3 lies on the graph of the function f of x. If the function is transformed for f of x minus 3 plus 6, which of these will be the coordinates of 2, 3 under the transformation? The first transformation I do, guys, is always the x coordinate. So this right here, really the x minus 3 portion, is telling you that you're moving 3 to the right. So if I move 3 to the right, let's see, 2 plus 3 is 5. So I'm looking for my x coordinate to be 5. That one has a 5, that one has a 5, out, out, out. So the next, that 4 that you have in front of the f, this 4 right here, that affects your y value. That's a vertical stretch. So 3 times 4 is 12, and then this plus 6 also affects your y value. So 12 plus 6, let's see, what's that, 18? So my coordinate that I'm looking for is 5, 18. Hopefully that made sense to you guys. All right. Question 7 is called the piecewise function, guys. I really would like for you guys to know this. It's not all that difficult. All it means is that it's in pieces. So if you wanted to make a visual really quick, let's see. I behave like the absolute value of x plus 3 minus 4 between negative 9 and 2. So let's see if we can figure this out. Vertex at negative 3, negative 4. So point, negative 3, negative 4, somewhere like here. And it looks something like this. I don't necessarily care too much about the y value for a negative 9. But I do care about the y value at negative 2. So let's see. Negative 2 plus 3 is 1. Absolute value of 1 is 1, but I have a negative here. Negative 1 minus 4 is negative 5. So that occurs at negative 5. And then this function at negative 2, let's see. 2 times negative 2 is negative 4, minus 1 is negative 5. So I'm back here at this location. I have a y-intercept of negative 1 and a slope of 2, and I go all the way to the value, the x value of 3. So it's going to look something like this. Again, a hole on both of them because I do not have an equal sign on any of them. So let's see, 2 times 3 is 6, 6 minus 1 is 5, so that has to be the y value of 5. None of this is to scale, guys, not to scale. All right, for x greater than or equal to 3, so this one's not going to have a hole. It's going to be a solid circle. So let's see, 3 minus 3 is 0. The square root of 0 is 0. 0 plus 7 is 7. So I start at 3, 7 point. I'm going to say that's 7. And it's just a square root function, so it looks something like that. Okay, now we're ready. The domain is negative 9 and negative 2. Notice parentheses on both. And negative 2 to infinity. Negative 9 and negative 2. 2 to infinity. Yep. You are defined at 3, guys, from this bottom one here. So that one is true. The graph of g of x has a jump discontinuity at negative 2. So I'm looking at negative 2. Sorry, this was negative 2 right there. I'm looking at negative 2, and that is not a jump. That is a hole. A hole is the same thing as saying a removable discontinuity or point of discontinuity. So nope, that is not true. The graph of g of x has a point of discontinuity at x equals 3. This is called a jump. There's a gap there. So that is not a point of discontinuity. That is a jump. So there it is. The only one that's true is number 1. All right, let's keep going. Number 8, the wheel on a car has a diameter of 52 centimeters. So that means that the radius is 26 and rotates at 600 revolutions per minute, or rotations per minute, same thing. What is the approximate linear speed in centimeters per second of a point on the wheel? Okay. So if I go, let's see, 600 rotations per minute, so I'm going to say 600 revolutions per minute. That's what it says. And in one revolution, the ground you cover is 2 times pi times r centimeters. So right now I have centimeters per minute. Remember that circumference of a circle is 2 pi r. So that's how many, so the distance that one full circle is or covers is 2 pi times 26. So now the next thing I got to do, I don't want centimeters per minute, I want centimeters per second. So I say in 1 minute, I have 60 seconds. So there the minute goes away. I take my calculator, I have it here with me, and I go 600 times 2 times pi times 26. I push enter and I divide that sucker by 60, and you get 1,633.62818. And then if I have units, centimeters per second, I look up here. Since it says the word approximate, that's the best one. All right, let's keep going. Identify the location of any holes. the graph of this function. All right, so what we're going to do is we're going to factor out, guys. So I'm going to factor out a negative in the top, and I have x squared plus 4x minus 32. In the bottom, I'm just going to factor out. So two numbers that multiply to give you 24, but add up to 11. So that's 8 and 3. So I'm just going to say x plus 8, x plus 3. And let's go ahead and factor out the top while we're at it. Two numbers that when you multiply give you negative 32, but add up to a 4, positive 4, and it's going to be 8 and 4. So here's what I have. Negative on the outside, x plus 8, x minus 4, over x plus 8, x plus 3. The x plus 8 cancels out. So whatever factor cancels out is where you have a hole. So where do you have a hole? You have a hole at x equals negative 8. Maybe I see this one has 2, so that one's out. No, no, and no. So it's probably going to be letter 8. Plug in x equals negative 8 into what you have remaining, guys, to see what the y value is. So let's see, negative, and then 8 minus 4. Negative 8 minus 4 is negative 12, divided by negative 8 plus 3 is negative 5. These negatives cancel out to be positive, but then divided by a negative again, I'm back to negative. Positive divided by negative is negative, so 12 over 5. There we go. Hopefully that made sense. Question 10. The graph of the function has a horizontal asymptote. If the graph crosses this asymptote, give the x-coordinate of the intersection. Otherwise, if the graph does not cross the asymptote. All right, so horizontal asymptote, that we're looking at end behavior of the numerator and end behavior of the denominator. I have a 1 here, I have a 5 here, and I'm looking at this in particular because those are the highest degrees. So my end behavior is 1/5. So my horizontal asymptote is 1/5. Next, I'm going to go 1/5 equals, and I'm going to say that expression, x squared plus 3x plus 8 over 5x squared plus 9x plus 9. I'm going to cross multiply. 5x squared plus 9x plus 9 equals, let's see, 5 times x squared, that's 5. Oh, it does that from time to time, guys. I don't know why, but can I get back to normal here? All right, here we go. 5 times 5x squared, that's 5x squared. 5 times 3, that's 15x. And then 5 times 8, that is 40. So the 5x squares cancel out. And then I'm going to subtract 15x. I'm going to move the x to the left and the whole numbers to the right. So minus 15x minus 15x. So 9x minus 15x is a negative 6x. And then minus 9 minus 9, that's going to be a 31. And then divide by negative 6. And you get x equals a negative 31 over 6. And I'm going to be looking for that answer. And there you go. All right, here we go. State the coordinates of the vertex. So what we're going to do is complete the square. I'm going to grab these two. So what I mean by complete the square, guys, is that I want it to look like this. So that's what I'm going to be doing. So here we go. I'm going to factor out a 4. And now I have x squared minus 4, 8, 12, 16, 20, 24. So that's 6x. And I still have that plus 43. And then I take this number 6 here and I divide that guy by 2. So 6 divided by 2 is 3. And then I square it. 3 squared is 9, so I'll put plus 9. So what you really did is make it heavier by 36. So you subtract 36. So now here's what you have. 4, x minus 3, close it squared, plus, and the difference between 36 and 43 is 7. So my vertex is located at 3, 7. Let me know if you find any errors, guys. Why isn't it responding? There we go. All right, so given the function x squared plus 6x plus 3, find the difference quotient. All right, so here we go. We're going to find the difference quotient here. That's already f of x. I need f of x plus h, so I'm going to write f of x plus h. F of x plus h equals x plus h, close it squared, plus 6 times x plus h plus 3. All right, continuing, x times x is x squared, x times h is xh, but I'm going to have 2 of those, so 2xh. H times h is h squared, plus 6x plus 6h plus 3. And then from there, I'm going to combine like terms. There's nothing to combine. So now I'm going to do this part right here. So f of x plus h minus f of x all over h is equal to, and I'm going to write this expression again, x squared plus 2xh plus h squared plus h squared plus 6x plus 6h plus 3 minus my f of x, which is x squared plus 6x plus 3. All this is over h. Notice I put a parenthesis right here. So when I distribute that negative, the x squares are going to cancel out, and then the 6x's cancel out next, and then the 3's cancel out next. That should always happen. So what you have left is 2xh plus h squared plus 6h. And you should be able to factor out an h relatively simple. And if we factor out an h, you have 2x plus h minus 6. All over h, the h's cancel out, and there it is. All right, let's continue. So this is the composite function. So here we go. F of 5. F of 5 equals 5 minus 4. 5 minus 4 is 1, and that's what you're going to plug into g. G of 1 is 4 times 1 minus 2 times 1 squared. So 4 minus 2 is 2, and there it is. All right, next one, guys. This is the inverse function. This is the original function. So this was a y on original. So I look for that value, and I see negative 2. So there it is. And in case you're wondering, because I don't want you guys to be a robot, when you take the inverse of something, guys, it turns into y comma x. And the reason it does that is because it reflects across the line y equals x. All right. Find the linear function f with y-intercept 3. So I already know that my y-intercept is 3. And a coordinate, and that coordinate. Well, remember, that's the inverse coordinate. They don't want the inverse. They want the original. So that means my original. Sorry, guys. There's something going on here. Either my pen's running out of battery or my pen's running out of ink. One of the two. Guys, I'm kidding. It's a digital pen. It can't be running out of ink. You guys are funny. All right. So here's my coordinate, negative 1, 0. So there it is. So that's all I really need. So if you think about it, you have a coordinate at negative 1, 0, and you have another coordinate at 0, 3. So I have a positive slope out. And it's easy to calculate, guys. If you think about it, negative 1 and 3. So if you think about it, let's see, going up 3, right 1, my slope is 3. So that's easy. So 3x plus 3. Hopefully that made sense to you guys. Right, this one here, I'm going to plug in x plus 1 in for x and see which one it looks like. So x plus 1 squared minus, I don't want to write now, x plus 1. Come on, guy. All right, so when I do that, you have x times x is x squared. X times 1 is 1x, but you're going to have two of those. 1 times 1 is 1. And then you distribute that x there, minus x minus 1. So you have x squared, and then 2x minus x is x. And then x, the 1's cancel out. So you have x squared plus x. And now you're like, all right, Chavez, I don't get it. What are you trying to prove here? Well, it has to be this one here, guys. Because notice the original, that x squared stays as x squared. And then that minus x turns into a positive when I do the x plus 1. So, Chavez, I have no idea what you're talking about. Can you explain this better? Yes, I will. What I'm trying to say is that if I were to insert negative x, so let's see, negative x squared minus a negative x, you can see here, negative times a negative is a positive, and I'm still going to have x squared, and then negative times a negative is a positive, and I have plus x. So x squared plus x is what I have, so this is equivalent to inserting a negative x. So letter D. All right. In a right triangle ABC, the right angle C, so I'm going to draw a right triangle, right angle C. AB is 12, so it doesn't matter which one you put A and which one you put B. So AB is 12 and BC is 6. Find the length of the missing side. Oh, you just do Pythagorean theorem, guys. 12 squared minus 6 squared and the square root of that. So 12 squared minus 6 squared. And I get 108. And 108 reduces to 36 times 3. And the square root of 36 is 6. So 6 square root of 3. Alright, let's go to the next one. Name the quadrant which the given conditions are satisfied. I want tangent to be positive. Alright, so here's my quadrants. Tan is positive here. And tan is positive in quadrant 3. And I want cosecant to be negative. Cosecant is reciprocal of sine. So cosecant is negative here. And cosecant is negative in quadrant 4. So the one that it's on both is quadrant 3. So there it is. Rewrite the following expression in terms of its reference angle, deciding on the appropriate sign, positive or negative. All right, tan 196, again, it's right here in quadrant 3. And we just talked about tan being positive in quadrant 3. The reference angle in quadrant 3 between 180 and 196, that's 16 degrees. So since we know that tan is positive, letter A. All right. And C stands for no calculator, guys. This thing's buggy again. There we go. I wonder if it's because I'm using this new battery charger. All right. Okay. Where is cosine negative square root of 3 over 2? On the unit circle, cosine is negative square root of 3 over 2 in quadrant 2 and in quadrant 3. So they notice that they don't have the traditional 5 pi over 6, but they have this negative 5 pi over 6. And yeah, if I do this, that is negative 5 pi over 6. They have negative pi over 3. No, negative pi over 3 would have been in quadrant 4. That is not it. And then they have pi over 3. 5 pi over 3 is again in quadrant 4, so just the first one. All right, let's keep going. This one wants the exact value of tan of 2 pi over 3. So before we continue, remember that tan 2 pi over 3 is in quadrant 2. So y divided by x in quadrant 2, you're going to get a negative output. So delete anything that is positive. So now it increases your chances of getting this one right. So y divided by x. So the y value there is square root of 3 over 2. And the x value is a negative half. So you're going to get negative square root of 3. Because the 2's cancel out. 22, the measurement angle B is 49 degrees. So put 49 degrees right there. And C is 9, or little c. What is the value of B? Okay, so respect to 49 degrees, that B is opposite, the 9's hypotenuse. So I'm going to write sine 49 degrees equals opposite B over 9. So 9 sine of 49 degrees equals B. So I take my calculator, make sure that the mode is in degree mode, and I go 9 sine 49, and I get 6.792. Which of the following angles the radian measure is greater than 225 degrees? If you want, just multiply all of these by 180 over pi times 180 over pi times 180 over pi. When you do that, you'll get a degree. So let's see, 3 times 180 divided by 5. So this is 108. And then 7 times 180 divided by 5. You get 252. And 5 times 180 divided by 3. And 300. Yes, you could probably just look at it and figure it out. 252 and 300, so 2 and 3. All right, last one here looks like. Which of the following is equivalent to this particular guy? So I need a common denominator. I'm going to multiply this term over here by cosine theta over cosine theta. When I do that, I get sine squared theta over cosine theta plus cosine squared theta over cosine theta. And then we recognize that we have sine squared theta. Sorry guys, again, my pen's not working as well. Plus cosine squared theta all over cosine theta. Sine squared plus cosine squared is 1. So 1 over cosine theta, and 1 over cosine theta is secant theta. So secant. Alright guys, so I hope you guys enjoyed this video. I don't know, my laptop's acting kind of funny, but I guess that's fine. Hopefully it'll fix itself over the weekend. And hopefully you guys are ready to go. See you guys in a few days. Alright, later guys. Bye.